Bismillahirrahmanirrahim. Assalamu alaikum. Welcome students to the video lectures. Today's topic is turning effect of forces. Let's begin with the idea of a rigid body. A rigid body is an ideal solid body or the object which does not change its shape or size, or we can say that in which the distance between any 2 points never changes. No matter how much force you apply, it does not bend, stretch, or squash. Let's see the figure. Here we have two blocks, A and B. The force F1 and F2 acts along the same line in the opposite direction, but still no deformation occur or no change in size or shape or distance is not changed. In the figure B, you can see again F1 and F2 are not acting along the same line but at the two different points, but again no change in shape or size. Rigid body is considered as perfectly hard, though in real life body deforms slightly, but we are talking about the ideal situation in which no change in shape or size. The motion of a rigid body can be of two main types, translational motion and the other one is rotational motion. Translational motion is a motion of a body without rotation that can be in a straight line. For example, a motion of a car or motion of a ball. That can be along the circular path and the motion of a body along irregular path. For example, the motion of butterfly. Rotational motion. Rotational motion is a motion of a body about a fixed axis of rotation, a spinning wheel, a rolling ball, or a door swinging along hinges. Here, this shows that a body, this is the axis of rotation about which a body is rotating. Axis of rotation. A straight line about which a rigid body rotates is called the axis of rotation. Axis can be fixed like a ceiling fan or moving like a rolling wheel. This axis may or may not lie within the body, like Earth rotates about its axis. As you can see the Earth in this figure, it is rotating about its own axis. Now this line is its axis of rotation. Ferris wheel rotating about its axis. Spinning top axis is this and it is rotating about it. Rotating blades of a helicopter. Every particle of a body moves in a circular path around the axis and the particles on the axis remains stationary. Again, giving you the examples of the spinning top, car's wheel and the earth. Now the line of action of force. The line along which the force acts is called the line of action of force. If you can see the figure, this line is the point where the force is acting, so this is the line of action of force. It determines the torque produced by the force. What is torque? Basically, it is the moment. And how we can understand what is moment? When the force is acting at some distance about a fixed point, this is the fixed point, the turning effect is produced if it is acting through some distance, and this distance will be known as perpendicular distance, or we can call it a moment arm. And due to this force, what can be done? A torque or the turning effect can be produced. If the line of action passes through the axis of rotation, no rotation will occur. If this force will act at this point, then there will be no movement. But if the force will act like this at some distance, and this is called as perpendicular distance, as you can see the force is acting perpendicular to this point. So in this situation, the moment will be produced, or you can say that the torque will be produced. The perpendicular distance between the axis of rotation and the line of action is called moment arm. As you can see here, this distance is called moment arm. Pushing, the examples are pushing a door at the edge, line of action does not pass through the hinge, door rotates. Pushing a door exactly at the hinges, line of action passes through the axis and there will be no rotation. In this situation here, when we talk about door, it will be hinges. If you will apply the force at the hinges, door will not rotate, means that you cannot open or close the door. Similarly, if you will apply the force on the knob, you will simply open the door. Introduction to the turning effect. A force can cause not only motion in a straight line but also rotation, as we have already discussed, that if the force acts at some distance from the fixed point, that fixed point is the axis of rotation, then the turning effect may produce. For example, opening or closing a door by applying a force at its handle. This effect is called the turning effect of force, or we can call it a moment of force or torque. Now let's get the more accurate idea of turning effect by seeing the activity here. Here we have a seesaw's picture on which two children or a person are sitting. This person is having a greater force, means greater weight, acting downward, and this is the fixed point or axis of rotation, and we can call it pivot or fulcrum as well. It is at 1 meter's distance and the other one is sitting at 2 meters distance, as it has a smaller force. Due to the greater distance, both are producing moment and managing the seesaw on both opposite sides. When these two are sitting at the opposite sides of the seesaw, the one who is having a greater distance or who is sitting farther is producing greater turning effect. So we can say that with the help of this example, we can show the turning effect depends on force applied and the perpendicular distance from the axis of rotation. Moment of force is equal to the force into perpendicular distance. In SI unit, its unit is Newton meter. The moment of force can cause clockwise or anti-clockwise rotation, and its formula is tau is equals to F into L, where tau is torque, the turning effect or moment, F is equals to the applied force, and L is the perpendicular distance from the axis of rotation. From this figure, you can see that the line joining OP, the force line of action of the force, is not perpendicular to OP. So the component of force is responsible for the turning effect. Similarly, in this figure, the line joining OP, F again not perpendicular, and here the moment arm, component of moment arm will be the responsible one for the turning effect or producing the torque. Note that if force passes through the axis, moment is equals to 0. Application of turning effect are opening or closing the door, but the force should applied at the handle, using spanner to open or tighten a nut, and pushing a switch. Now let's see these situations. We have got 4 situations here, A, B, C, and D. Here in the situation A, this is the line of action of the force, this is perpendicular distance, and simply the turning effect will be produced. In situation B, as torque is F into perpendicular distance, the effective distance is taken perpendicularly, not along the slant, and still the rotation will be produced. In this situation, it is just similar as the situation A, so the turning effect will be produced. The only distance is the spanner is the shorter one. This one is longer, that will produce the greater turning effect. This spanner is shorter, but still the rotation will be occur. Now here, in D situation, the force, line of action of force is along the axis of rotation. So no turning effect will be produced. Finally, we will discuss about couple. When we say couple, it means in pair, or when two equal and opposite parallel forces act at two different points on the same body, they form couple. For example, opening and closing a water tap, turning a steering wheel of a car. In both the above examples, we apply pair of equal forces in opposite directions. The torque produced in this way is known as couple. Now let's see this figure. This is a body AB. Here two forces F1 and F2 are acting at two different points, and these forces are equal in magnitude but opposite in directions. This is the axis of rotation, and now what will happen? The turning effect will be produced. Here we have got a distance OA and OB. So we will take it not a moment arm, but the total distance will be called as couple arm, due to which the rotation will be occurred. So here the torque produced by the couple will be equal to F into AB. So the total distance AB and F1 is equal to F2. So we will take it as F. The examples of couple are the steering wheel of a car, and you can see the forces applied on the pedal of the bicycles. Thank you, students. I hope you understand everything we have discussed today.